Ooh.
Yeah, it's just a. It's got a 10-minute video of it. Obviously, the 10 minutes that we've done.
Anything yet?
I can't even see the.
Okay, can somebody refresh YouTube because it looks okay from here?
That's what I'm just trying to do. I can't even find the link.
Oh, it's refreshed, I think.
Is it okay?
I've got Sonia's name on the YouTube now.
Right, that's fine.
Yeah, we're back on again.
Right, sorry about that, viewers. We had an unexpected shutdown of our streaming connection. I've managed to get it back up, but let's hope it lasts. So apologies for that. Anyway, Roger, you were saying.
Okay, so we'll progress on, and we've now got Sonia's picture. She's done with her 10-inch Dobsonian and Pixel Pro 8.
Mm-hmm.
Lovely. Well done, Sonia.
Obviously. And one from a drone of the noctilucent clouds on the 23rd of June.
Oh,
Ooh.
That's good.
Yes.
I like that.
Well, if you haven't got a clear line of sight, then obviously using a drone about 50 feet up in the air would probably be useful, wouldn't it?
Can somebody just check the stream again, please, on YouTube?
Yes, it's coming on. I think we're getting the viewers are coming back on again.
Good. Yeah, viewer count's going up. So good. Okay. That's beautiful. I've never seen noctilucent clouds. It's on my long list of things I've never seen, like a solar eclipse or an aurora. So I'll have to get through that bucket list before I shuttle off this mortal coil.
So that's from the entries that we had this week, and hope you've enjoyed it.
Yeah, right. Very good. Thank you for that. Yeah.
Thank you very much, Roger. That's fantastic. Okay, well, let's move on with this week's news. Quite a few things in the news this week. So let's move straight on with that. Just give me 1 second, and we will go. Okay, so fantastic news. You may remember that at the beginning of June, the Chinese launched the Chang'e 6 lander to the moon's surface. It landed on the far side of the moon, which is not an easy thing to do. They had to launch a relay communications satellite in orbit around the moon so they could get signals back from the far side. Its ambition was to collect 2 kilograms of sample of the moon's soil, the regolith, from the far side of the moon and return it to the Earth. Now, why is this important? It's important because the geology of the near side of the moon and the far side of the moon is very different. You probably realize that the near side of the moon is characterized by the mare, the ancient lava plains, whereas the far side of the moon has got virtually none of them. So the big question, of course, is why are the far side of the moon and the near side so geologically very different? And returning samples that we've never had before returned to the Earth from the far side of the moon is obviously a big scientific bonanza. And this morning in Mongolia, the probe made it back to the Earth, dropped off in Earth orbit by the returning spacecraft, and the sample canister made a perfect descent onto the Mongolian desert. And the sample is now in the hands of Chinese scientists, and they have said that they will share the samples with the scientists of the world. So this is good international cooperation, no matter what might be going on politically between countries. Science, of course, always carries on internationally. So all the world's scientists will get their own little bits of this 2 kilogram sample to analyze. Lou, any thoughts about what we might discover?
I don't think it's clear why the geology of the near side and far side moon are different. Although once it was gravitationally locked, that provided some protection for the near side. And so perhaps the far side is different because it has had more population from meteor strikes, but I don't know.
Yeah.
Yeah, because there is the theory that, as you said, it was locked. So we're only seeing the one side, but also that kept the near side more malleable for longer, so that more any meteors that hit or meteorites that hit the moon on that side actually cause the lava flows. That's one theory. So being tidally locked, then it was it stayed warmer longer. So yeah, there's several theories.
So could it be, I'm sure it is something to do with the late heavy bombardment epoch about 3.5 billion years ago, and perhaps the near side was just protected because all the bodies that struck the moon were coming from the direction of the far side, and that obviously got pummeled a lot more. I don't know. That's just just what I was.
Hopefully, we'll get some answers from this.
Yeah, absolutely.
Yeah.
So anyway, well done, China. The safe return of the Chang'e 6 far side sample from the moon. It was an immensely complicated mission for which China should be heartily congratulated, because it had several components. It had an orbiter which dropped the lander onto the surface. Then the sample had to be scooped up, and we looked at that a couple of weeks ago in a video of the actual taking of the sample. Then there was an ascent stage on that lander, which then had to rise to lunar orbit, rendezvous with the orbiter, and then come back to the Earth. And then the spacecraft had to drop the sample canister you see in front of you. So it was engineering-wise quite a complicated mission, but it all worked absolutely perfectly. So again, well done, China. Now, the James Webb Space Telescope continues to make amazing discoveries, but it's proving its worth as a survey instrument as well. And it's recently taken something that we are familiar with from the Hubble Space Telescope, which is a deep field image. And that is to just open the camera at a particular point in the sky and do a really long exposure to see what it could find. The latest image from the Webb Deep Field is this one. Does anybody know what the objects in the circles are? These are supernovae. There are more than 80 of them in this image. So these are supernovae at various points throughout the universe's history, going right back, in fact, to not long after the Big Bang. And in fact, the youngest supernova that the Webb has so far discovered happened only 1.8 billion years. I mean, I know only 1.8 billion years like it's nothing, but we have to speak in astronomical terms. Only 1.8 billion years after the Big Bang. One of the prime goals of the Webb, of course, is to discover the so-called population 3 stars, the universe's first generation of stars. And these stars were characterized, as you might expect, by being very metal poor. And what we mean by that is they contain only hydrogen and helium, unlike later stars, of course, which contain lots of elements that had been seeded through the universe by previous generations of supernova explosions. And what we're looking at here are some of these supernovae that the Webb has seen, some more recent, some a lot older. By looking at the really early supernovae, we might get some clues about how the first generation of stars in the universe actually evolved and died. So this is quite an important thing to do. Of course, one telescope that will be ideally suited to this sort of survey work will be the Vera Rubin telescope in Chile when it sees first light. I think at the moment they're saying towards the end of next year, because that will photograph the entire southern hemisphere sky every 3 nights, and it will be easy to spot things that are new, things that have moved, things that have disappeared, and it will do so over a period of 10 years, and that is going to unleash a treasure trove of data, a vast amount of data, physically a vast amount of data about things that are changing in the universe. So we look forward to that. Moving on, well, let's just zoom in a bit here. You can see the sheer variety of the supernovae because none of them look alike. An amazing image from the Webb. And this is the supernova I was talking about. It was 1.8 billion years after the Big Bang. This presumably massive star went supernova, and that holds the record now for the oldest supernova ever discovered, thanks to the James Webb. And there's been an interesting discovery about a galaxy. Now, what this galaxy is was a humdrum, nothing out of the ordinary galaxy, and it's got the catalogue number of SDSS 1335 plus 0728, which is, of course, its coordinates on the sky. It's 300 million light years away, and in 2019, astronomers noticed that it was getting brighter. And at first they thought their measurements were wrong, but they weren't. And since 2019, this galaxy has been getting progressively brighter. What was going on here? Well, what's happening is that the supermassive black hole at the center of this galaxy suddenly started feeding voraciously on material that it had swallowed, and has continued to eat that material for the last 5 years. And this has sort of lit up the whole center of the galaxy in a way that we couldn't see otherwise. And here's an animation of exactly what that looks like, or has looked like. So this has lit up the galaxy and told us lots of things about it. And it's all due to this supermassive black hole, for whatever reason, suddenly starting to feed voraciously. Perhaps it swallowed a star, or more than one star as it got too close to it. We don't know, but it's really another piece of incredibly useful information for astronomers who study the evolution of supermassive black holes. Now, when you do have a galaxy that is feeding voraciously on material that is spiraling into the black hole, we call these active galactic nuclei, and they can outshine entire galaxies on their own. Don't forget, this is not the black hole itself glowing. This is the material that's falling into it, becoming superheated and radiating light across the electromagnetic spectrum. And this is why we say that black holes are actually the brightest objects in the universe. Not the holes themselves, of course, which are black and therefore invisible, but the material surrounding them can outshine entire galaxies. So this was quite an interesting find. We've never ever seen a black hole suddenly come to life like that. And we're going to stick with the subject of luminous galaxies for the moment. As you may know, these ultra bright objects, which were dubbed quasars, that is quasi-stellar radio sources, because initially they were only visible in radio waves. These are towards the edge of the observable universe, a lot of them. They are so far away that their light takes billions of years to get here. And this is what a typical one would look like. This is a quasar called J03131806, but all quasars are fairly similar in the way that they behave. So you have the supermassive black hole at the center. In this particular case, with this quasar, it's 1.6 billion times as massive as the sun. Then you have surrounding that the accretion disk, this very, very hot material radiating copious quantities of X-rays as it heats up, and lots of other EM radiation as well, and surrounded then by the host galaxy. But what's interesting, well, it's all interesting, but one particular thing is that there's an outflowing of radiation from the black hole across the galaxy, which can be incredibly powerful, and these are known as the black hole winds. Now, these can travel at 20% of the speed of light, and the reason they're interesting is because they can have an effect on star formation in the galaxy. The pressure of all of this radiation can dispel clouds of molecular hydrogen that otherwise might have collapsed to form stars. So black holes can actually act as a sort of a throttle on the formation of stars in a galaxy. And this is a fact that's only really come to light in the last 10 or 15 years, that black holes, as well as being immense monsters at the centers of galaxy, can affect the whole evolution of a particular galaxy. And these incredibly bright objects, where the black hole is swallowing unbelievable amounts of material, are known as quasars. Now, I mention all this because there's been a new discovery about a quasar called SBS 1408 plus 544. It now holds the record for the fastest of these outflow winds from the black hole. And does anybody want to guess how fast that radiation is moving away from the black hole? Anybody want to take a guess? No? Okay. Well, it's moving away from the black hole, which is at a distance of 13 billion light years. So again, this is in the very, very, very early universe. And the speed of those winds speeding away from the black hole has been measured at 36 million miles per hour, or 58 million kilometers per hour. And these are the fastest black hole winds ever discovered. And again, you know, they would have an effect on the evolution of the host galaxy, and the relationship between the supermassive black hole at the center of a galaxy and the evolution and star forming capability of that galaxy, we're only just really beginning to understand. But we're discovering things like this all the time now. So there we are. Moving to another topic altogether. Nobody will probably recognize this, which is fine. This is actually a pallet that was ditched from the International Space Station, weighing about 2 tons. And it's a pallet of expired batteries that have been used for various things on the International Space Station. And as you can see, this was released from the International Space Station in 2021, and it was thrown overboard. And of course, its fate was that it would burn up in the Earth's atmosphere. Except it didn't. In fact, one of those batteries that you can see here came crashing through the roof of a house in Florida recently, fell through 2 floors, and narrowly missed a 2-year-old boy. And the family in that house are, well, should we say, a little bit miffed, and they have filed a claim with NASA about the damage to their house. Interestingly, and I didn't realize this till I looked into it, US law says that US law organizations like NASA are allowed to give compensation and damage claims to people who suffer as a result of space debris outside the USA, but there's no law governing people who actually live in the USA. So the law stands at the moment, if the whole International Space Station dropped on a house wherever in the USA, nobody could claim anything. And there's now a big push to change that loophole in the law, which means that anybody, regardless of where they are, can file a claim if they happen to get pelted with debris. And meanwhile, in North Carolina, this is littering a climbing path in North Carolina, and this is one bit of it. And there was a lot of it apparently distributed over this mountain where this path is. And this is actually part of a SpaceX Dragon service module that didn't break up in the atmosphere. And again, if somebody had been standing underneath that, you can imagine what might have happened. So space debris, as always, is a growing problem. And things that are expected to burn up in the atmosphere sometimes just don't, for whatever reason. The ongoing saga of, yet again we return to it, the Boeing Starliner has had its return to Earth with the 2 astronauts, delayed until July the 2nd at the earliest. They are still investigating the problem with the thrusters. As you may remember, they discovered 5 leaks, helium leaks, in the spacecraft, which on return through the atmosphere would affect the ability of the spacecraft to perform the move as it needs to return safely to the Earth. So this has been put off again until July the 2nd to allow the NASA and Boeing teams time to try and work out what the hell they're going to do. Calls are mounting, of course, for SpaceX to mount a rescue mission to rescue the 2 astronauts. But this is all sadly misinformed. There is already a SpaceX Dragon that is docked with the ISS at the moment, and all it would mean is that the 2 astronauts would have to stay as long as the others on the International Space Station until their tour is ended and return with them to the Earth. So that nobody's in any danger, and there've been all sorts of clickbait headlines about this, and astronauts in danger, astronauts lost at the space station, etc., etc. It's
warning.
Yeah, exactly. It's all a load of nonsense. Nobody's in any danger. If they can't fix the Starliner, then it's not going to endanger anybody. If they think they fixed it and the astronauts try to return to the Earth and it turns out they have problems, well, then we might start to worry. But as it stands, the astronauts are in no danger. They'll just have to stay a bit longer on the ISS than they anticipated. That's all. So don't.
Andy,
Yeah.
Will the supplies that they've got currently out there be dwindled a bit more than because they're staying up there longer?
Good point, Roger. Presumably, yes, but I don't know what they would do about that.
Yeah, they were saying before that they've got plenty of supplies up there to accommodate them. They did say for 2 or 3 weeks, but that of course that's now going to be extended to over a month. But also it's the water as well, because one of the things, if you remember, when it launched, it used a lot more water than was expected in the actual launch itself. And this now means that it appears that the International Space Station's water supply is going to be tapped to refill the top up the tanks on the Starliner. So it could be a drought situation. So that means sometimes they've got to take some more water up, and of course, water is heavy. So that's going to be what's the name?
But I think the big point is that nobody's in any danger.
No,
that's the important thing.
That's right. Yeah, I mean, what was it? Butch? He was in more jeopardy when they tried to put him in his spacesuit for walking. Apparently, he had a water leak, and of course, we had that before.
Well, it wasn't actually the spacesuit; it was the umbilical.
Oh, okay. Then. But yeah, they've had crews nearly drown, haven't they? In the
if the spacesuits were fine. When they are exiting the ISS, they are temporarily attached to an umbilical, and it was that umbilical which sprang a leak. And because they hadn't even left the ISS at that point,
that was it.
Yeah, they didn't actually get outside. So
because that was the second time they tried to go for a spacewalk, wasn't it?
You've got to remember how old all this stuff is.
Oh, exactly, yeah. And this takes me to another subject, about the lunar gateway, but we won't talk about that today. Right. But going back to the space debris thing, what you were saying is correct about that NASA and all that cannot pay monies to when incidents of space debris fall on somebody's property.
No, that's right.
The old ancient law, as it is, to be quite honest, it goes all the way back to the 60s. It says that if anything falls on your land, if you want to make a claim, you have to go to your government, to then contact the government of where the actual spacecraft came from, and they've got to negotiate reparations.
Yes.
But of course, that would mean the US would be trying to contact the US.
Yeah.
So of course, there's no litigation. If somebody gets injured or killed, then it's a different kettle of fish, because then you can actually then go after the company that built the rocket. But other than that, nobody's held responsible. The two countries from where the rocket originated, from to the people who actually got the debris on their land or whatever, or through their roof, they've got to negotiate their own way around it. And that it's very, very it's counterproductive, like you say. But the US cannot sue the US.
No, exactly.
I mean,
exactly.
That's how that works. That's why you can't do that. So
anyway, moving on. We're going to move on to talk about what you probably saw in the thumbnail. There have been some recent interesting studies of coastal erosion on Titan. And we're going to let Lou now talk about exactly what that's all about. If you're ready, Lou.
All set.
Okay, so there you
I I drew this presentation up, and originally it was "Surfs Up!" ! Latest findings on Titan's lakes. I think after reading through all the research, I'm going to say it "Surfs Up!" ? Latest findings on Titan's lakes. And what I'm just going to walk you through is kind of the whole process of Titan's surface atmosphere connection, and how lakes are formed, and what the probabilities are, and what the mechanisms are for perhaps winds. So if we go now to the next slide, these are two images of Titan taken on the left by Voyager 1, on the right by Voyager 2. And what you're seeing here is not the surface. You're seeing photochemical haze in the atmosphere. And you'll notice a couple of things. First of all, the haze is kind of orange. And secondly, on the tops of both images, it's a little easier to see on the image on the right, the Voyager 2 image, but also present on the left where the image is kind of cut off a bit at the top. These are North Polar Hood, or what we call the North Polar Hoods. And this is an accumulation of hydrocarbons and nitriles kind of in the shadow in the wintertime of those hemispheres that changes the chemistry and composition of the higher latitudes at those times. So what we're seeing here is the result of chemistry of photodisassociation of nitrogen and methane into smog, kind of micron, submicron sized particles. So we're seeing smog. And this, in fact, is the beginning or the basis for the formation of lakes, believe it or not. So here we're seeing a very different image of Titan. This was taken by the Cassini orbiter from its VIMS instrument, the Visual and Infrared Mapping Spectrometer. And VIMS was built to see through that smog. And it turns out between 1 and 2 microns, there are 4 or so windows between methane absorption lines where you can see all the way to the surface. So in this image, we see dark regions, which are the lakes, if you will. There are some kind of white localized features, which are almost certainly methane clouds or methane clouds, as well as surface material. So we can see with the right instruments through the haze. This is a radar image. Now this has been colorized, so these aren't the right colors, but the idea is that Titan has lakes, which is a result of its interaction with the atmosphere. And you can see some of the lakes here. We're going to be talking about Kraken and mostly, but all of these lakes are rather large and actually have quite some depth to them. Now, why did the lakes form? Well, this is a spectrum, an infrared spectrum of the atmosphere of Titan. And what you see are molecular emission lines in emission over a background of a surface emission and aerosols. And there's just an enormous potpourri of chemicals in the atmosphere, because as the methane and nitrogen are broken up, they recombine in various ways and produce all these really amazing hydrocarbons and nitriles. Okay, so they exist in the atmosphere. And as these aerosol particles that I mentioned drift down slowly through the atmosphere, the temperature in the stratosphere gets colder and colder and colder till about 40 kilometers. And as the temperature gets colder, these species, these molecules, these hydrocarbons and nitriles precipitate out. These are precipitation curves against the thermal profile of Titan's troposphere up to 40 kilometers, and then the stratosphere. So you can see where these species intersect. the temperature profile, they will condense out. And these submicron-sized aerosol particles that are slowly drifting down provide the perfect nucleation centers to help these gases glomp out of solution. And so you're building kind of what you might think of as sort of a large rain droplet with tears in it, or perhaps something like a slushy hailstone. And this stuff is falling to the ground. Oh, by the way, the image on the left is from a paper that I did just with the Voyager data in North Polar high latitude, around 60, 70 degrees on Titan. And the one on the right is from Cassini, Sears infrared spectrometer of the southern hemisphere. So in both hemispheres, there's condensation. And so from all of this, we can start to build models that aerosols trickle down, species of molecules condense out. At some point, they form clouds. These are methane clouds. And these clouds eventually rain down on the surface. And the methane and ethane is the dominant volatile in the stratosphere, methane in the troposphere, along with other minor species. They collect on the surface and produce lakes. Now, the methane also evaporates back up, forms more clouds, and rains back down again. So that's the methane cycle on Titan, which you might think of as analogous to the water cycle on Earth. All right, so now we have lakes. Okay, well, what do we do with them? Well, the question was, and there was a piece of research that suggested that there might be erosion of the lake fronts from waves, from waves in these hydrocarbon lakes. So that was arrived at through various models. And so the question then is, what would be the physical mechanism? These are some models of wind speeds on Titan, various models that have been developed from, Mike Flaser, for example, who was on the Voyager and Cassini infrared teams at Goddard Space Flight Center, and others, showing that from orbit and from the Huygens lander, we have evidence that the wind speeds at the surface are quite low. Perhaps they're certainly less than a meter per second, probably on the order of 0.2 of a meter per second or less. So the wind speeds at the surface of Titan are quite a bit less than the winds on Earth. But as you move up in altitude, the wind speeds can get larger and larger. And the wind speeds that Titan measured were upwards of about 120 meters per second at 120 kilometers. And these are zonal winds. These are kind of east-west winds that are driving this. The meridional winds, the north-south winds, are not that strong. And this is because it has very slow Hadley self-circulation because of its slow rotation. All right. So, there we are. So what is the mechanism? It would appear that there really isn't much in the way of waves on Titan. And this has been the long-held belief, certainly since Huygens. But a paper came out recently. Let's see, here we go. Paper came out recently by Rose Palermo and others, published in Science Advances in June of this year, recently, June 19th. Where they ran some models, and they said, well, let's look at the physical properties of the shorefronts of these lakes, and let's compare what they look like to the physics of what might form them. And so they looked at models of no erosion whatsoever on those lake fronts, as well as erosion from battering waves, as well as erosion that was experienced from a liquid that was just slowly eating away at the lakeshore material. And what you see here in this graphic, this triangle, On the sides, these numbers represent probability. And what you see in the reds and blacks on the bottom are either no erosion or slow erosion from liquid just eating away at the lakeshore material. And up here in the blue dots in their models, that is erosion caused by winds, by waves. And it turns out that the observations that the Cassini radar instrument has made would be more consistent with wave-like erosion of the shorelines of these lakes. Now, so I want to point out this is one paper, one recent paper. You don't throw out a piece of evidence, but you don't call it definitive yet. And it is indirect evidence, right, based on models of the existence of waves, which would require, I think, the somewhat stronger winds, surface winds. So I'd say this casts some doubt, but it is in light of quite a bit of evidence that suggests that the surface winds are extremely light at the surface of Titan. So we present this for your consideration, and we'll be on the lookout, as our Space Oddities team always is, for other pieces of corroborating or even rejecting data. And we'll follow this through as we get more evidence. So that's it, Andy.
Great. Thank you very much, Lou.
Ian asked,
Lou, that there was a study quite a few years ago now that said that the lakes on Titan can't raise waves more than 1 millimeter in height, and that they're sort of like a mirror surface because they're not disrupted by ripples, if you like, at all. There is that. How much evidence that was based on, I can't remember. I can't remember what the argument for that was. It was to do with the reflectivity, I think, that Cassini saw. And because the surfaces are very much, they've got a really high albedo, as we know. They reflect, an awful lot of light. So, there is that. But we were talking earlier about what the actual shorelines are made of. What's the geology? I mean, could liquid methane, for example, melt the ice that we presume is on the top of the shorelines? Because, liquid methane is, the whole moon, as you know, is incredibly cold. So what do you think about that, Lou?
Well, we know there's erosion that's happening because we see flow channels. We used to call them fluvial flows.
Oh, nice.
Right? So we know erosion is happening, likely over very, very long time periods. So I think the question is really just what is causing the erosion. Now, waves no more than 1 millimeter high are not much to talk about, but perhaps over long periods of time they would be. And we know that Titan has a slightly eccentric orbit around Saturn. Most orbits are eccentric. And so there could be a little bit of tidal movement, right? Just as we have with our moon around the Earth. So all interesting pieces of evidence. I think some of the strongest evidence is the direct observation of wind speeds that we got by tracking the Huygens lander. Now, so that's direct observation, but it's only one place. So true. I think we keep open mind about this.
Absolutely. Yeah, well, we will of course bring you any update on that. And as Lou said, it's only one paper, and presumably it's not had time to be peer reviewed yet, or has it? I wouldn't have thought. So it's come out very, very recently, only 5 days ago. So
because the ice that's covering the landmass, and as they say, some of the massive cliffs you see are pure ice. But it's not just ice; it's Rhimes ice, which is an ice that is very, very hard. It's almost as hard as concrete. And I know the only reason I know about this is that I used to be a member of SLU and a SLU ambassador, and of course they're on top of Mount Tidy, their telescopes, and they get some real good snowstorms up there. And one year they had the snowstorms, the domes were closed, everything started to sort of thaw, then it totally refroze again, thaw, refroze again, and it became Rhimes ice. So they had to wait for it to totally melt itself because they couldn't risk, because it turned to this Rhimes ice. They couldn't risk using jackhammers to clear the domes up there. So, but yeah, it's not just an ordinary ice. So it is very, very cold and very, very very hard, this ice. So yeah, it's an interesting one. Very interesting.
Yeah, it is. And well, while we're on the subject of Titan, Lou, were there any updates on Dragonfly, or are things still moving ahead?
Oh, on Dragonfly. Well, I believe they have what's called their CD funding, so it's full speed ahead in development.
Great.
I haven't heard much about the progress of the development, but I believe that I think I mentioned there's going to be a science education advisory panel formed, and I'll be a part of that. And I think now that they have their CD funding, they're ready to start pulling that together. So all impressions are that they're good to go. I think it's a late 2025 launch. Do I have that right? I don't know. Does anyone know? I think that's
2028, I think, wasn't it?
28.
Yeah.
All right. Well, that gives them more time.
Yeah, that's the last date I heard.
All right.
Yeah, I've got July
28. Okay. I'm thinking of Europa Clipper, which is
yes,
later this year, I think. So
yeah,
it's a neater event.
Yeah.
We're good to go, and they're when they set up their booths at NASA and APL booths at the major conferences. They have models of the Dragonfly, as well as virtual reality models where you can put the goggles on and actually walk through the spacecraft, take out instruments, and put them back in. It's really something.
That's cool.
Oh, that sounds cool.
Because also Europa Clipper is being launched like tonight on a Falcon Heavy, isn't it?
Yes.
Yes, it is.
So yeah, it's something to look forward to.
Yeah.
Oh, thank you, Paul.
Andy, can I just say something about the show tonight to viewers?
Yes.
If you clicked on like at the beginning of the program, please click on like again, because we had that break after about 10 minutes.
Oh, yes. Thank you, Michael.
Because
yes.
It's a brand new show now, so that won't count for this part of the show. So please like this.
Please like us a lot.
Yeah,
absolutely. And of course, your likes do help the YouTube algorithm recommend our videos to other people. So please, the more likes we have, the more likely we are to have more people watch our videos. Basically, that's how it works. So there we are. Okay, well, does anybody have anything else they want to say before we wrap up for this evening? We will, of course, be back in about 50 minutes for the launch of the... yes, Daz?
My son.
Sorry?
My son.
What?
So,
my son review.
Oh, God, sorry. I completely forgot that. All right, well, I just need to get set up for that.
Yeah, sorry about that.
Yes, I'm gonna let you do that in peace, and I apologize. I have to run off to yet another meeting.
Okay, thanks, Lou.
Great chat, Lou. Thank you very much.
Nice to see everyone.
Yeah, work on your jokes.
Yeah, absolutely. Yeah. Sorry, Daz. I was getting ahead of myself.
No, you're okay.
Okay, right. Just give me 1 second, and we'll.
I thought I was being kicked off.
Yeah, you are.
Oh, Ian found it fun. Ian found it funny.
Yeah. Okay. Just give me 1 second, and we'll sort that out. So, just advance to that, we will of course be back next week. With something that we don't know yet, obviously, but we will, of course, post the live stream as soon as we know what we're doing next week. So just give me 1 second and we will sort this out. Okay. Right, are you ready, Daz?
I am ready. Thank you very much.
Okay. So let's hear it then. What's been going on the sun this week then?
Well, not a lot. So it wasn't worth waiting. So you can take it off again now. No, it's been quite a quiet week. But we've got some old friends coming back, as Roger was saying, that were involved in the big storm a month or so ago. So and they're showing some promise. But unfortunately, it seems to be that once they come on to the eastern limb, then they seem to lose their fizzle for some unknown reason until they get to the western limb, and then they all start kicking off again and having hell of a party. So everything that we're going to see in a minute is all direct, any solar radiation or solar winds or anything like that is directed mainly away from us. We did have a big coronal hole which is in the northern hemisphere, if you remember from last week, but that rotated through. It did give us some enhanced winds, which pushed the KP index up. But basically, anything, if anyone was going to get aurora, it was around the Arctic Circle. It wasn't going to come down this far. So we started the week. This week we've had 85 flares, but as I said, most of them have been on the lower end, Cs or small M-class flares. We started the week with 6 active regions. We're finishing with 9. Sunspots, we finished last week with 150. We're down to 141 at the moment, but that's been going up and down. We've been down as low as 80 on one day this week. But it's been up to also 200, so it's been varying quite a bit on there. But we've got no coronal holes to show you at the moment. If you'd like to move on, Andy. Right, again, here we are. We've got our 100 seconds of the sun's activity over the week. You'll see there are quite a few sort of like minor flares going off. You'll also see a lot of filament action. You'll see filaments launching themselves. There is one that's sort of like in the 7 o'clock position, all the way almost up to where that dark spot is. Now, later on, right at the very end, that will actually launch itself. But as you can see, that was there's a big flare just come off of the eastern limb. And these are our old friends coming back round again. And when we do get to AR 3723, which is our old friend, it looks as though it's going to be very, very big. As you can see, we've got CMEs going off. There's some flares now happening. As I said, once they get on the western side, they all start having a party and kicking off and throwing stuff off. But there goes another filament just lifted off up in the northeast. But if you watch this, I know it's hard to watch, but all these flares going off. But what you're going to get, here comes the new one. What is it? 3723 on the eastern limb. This big blotch down in the bottom southwest. Now, if you look, this filament that's right on the edge of the western limb now is going to launch off at any time. There he goes, and he goes all the way back down to literally the center of the actual disc. The whole of that filament totally disappears. A lot of it is absorbed back into the sun, but again, what did actually launch was launched away from us. So we have Alex. You get a closer look in a minute, because I did actually make a short video showing some of the highlights of what's been going on. So if you'd like to go to the next one, Andy, we'll look at the coronagraph. And as you can see, we've got all this lovely stuff being thrown off, but nothing's coming our way. So unfortunately for us in mid-latitudes, there's no chance of an aurora. There are some big explosions. You can see there's one just going off at the 3 o'clock. And if you just watch it, but all this is away from us. And of course, during the week, we had the solstice on the 20th. which passed with very little events. Well, except for some idiots spraying Stonehenge orange. But as you can see, we've got lots of ejecta. But as I said, it's all away from us, and it's all away from Earth, and most of this is happening on the dark side. But that one thing I did notice, we didn't see any 360 halos like we did last week from the far side. So we've got to watch what's coming in from the eastern limb, and hopefully they're going to give us something so that we can see some aurora. Because I know a lot of people are expecting them to come again. But you can see this is all coming off of the 7 o'clock. That's all from our old friend three. Well, what's it called? All these numbers 3723 as it is now. And as I said, he was from our old. And look at that big one go off.
Wow.
That would have been lovely. So yeah, it's been it's been quite a slow week as regards things coming towards us. Although I will say now that we've gone from the week before where we had virtually all C class flares, we are now entering into M class flares. Most of them are small, but our friend that's just come back on, it did almost towards the end there. You hopefully caught a glimpse of a bit of a flash there. Because it gave us an almost X class flare. It was M9.3, so it was close, but it didn't win a coconut. And it wasn't Earth facing anyway. But yeah, so if you'd like to go to the next one, Andy, this is the short video of some of the things. This is a flare lifting off. It's just off to the left there of center. You can just see it lifting off. Here we got some flares going off. You can see the star thing coming up. Another launch of a CME there. Again, that's from the far side. And it should carry on. You can see a lot of it fell back again. Now this is in a different wavelength. This is 131 Armstrongs, and you can see all these flares going off. It helps you actually see them. Some of them are very, very dim. But it just shows you what's coming in from what's happening on the west limb, and also what's coming around from the other limb. Now this is that big flare lifting off, and that was today. That was early this morning. So it's you can see it's all lifting off. It's all, and then at the bottom you'll see it all evaporate away just as it so it completely disappears. So yeah, I think that's it, Andy. I don't think there's any more. So yeah,
thank you very much, Daz. That's great.
That's all right, mate. You take it.
Yeah. So there we are. So not an incredibly active week for the sun, and certainly probably no aurorae for us again. I've gone green again.
Yeah.
And
unfortunately, fantastic pictures. They look absolutely fantastic. Filaments, active regions, sunspots everywhere. But they haven't unfortunately produced the goods for us to enjoy any aurora. So yeah. So over to you, the Hulk.
No. So there we are. Yeah. I say this every time this happens. I must replace this camera because it's definitely the camera. But I will do that in due course. All right then. So we will be back at 21:45 UK time, hopefully for the launch of the GOES-U satellite on a SpaceX Falcon Heavy rocket. You may probably know the Falcon Heavy has not been incredibly in demand for launching heavier satellites, but it has a busy autumn coming up with several launches planned. And it is classed as a heavy lift rocket, although it has to be said, I think all of the satellites that it's launched so far have been well below its payload limit. Yeah. So it hasn't actually launched anything ultra heavy yet, but it is an amazing vehicle.
Yeah, a lot of that is due to NASA preferring certain other rocket makers. They're waiting on things like the New Glenn and ULA's what's it called, Vulcan, and things like that. And but of course there are now rumblings in the Congress and in the military saying, why aren't we using SpaceX? Not just because they can produce the goods, but they're far cheaper. They're not using expendable rockets. So, but yeah, there is a second launch later this year, and hopefully, if they sort themselves out, they'll realise that at the error of their ways, and they'll get the Falcon Heavy in more use. So yeah,
absolutely. And I don't know whether you saw this. As you may know, viewers, the FAA in the US has just released an environmental study about what would happen if SpaceX start launching Starship from Pad 39A at Cape Canaveral. So they had to do a lengthy environmental study, and the study basically says that SpaceX isn't going to affect anything in a major way, and that any problems can be got around. Guess who immediately released a retort to that, demanding that SpaceX not be allowed to launch so often from the Cape, and they shouldn't be able to do this, and they're endangering other companies using the Cape, and they're endangering civilians, and et cetera, et cetera, et cetera. You'll never guess who.
Oh well, it could be several people. I will say Mr. Bezos.
Of course, it's Mr. Bezos. Immediately came back with this lengthy, angry assessment of their own, which is not actually based on a lot of fact.
Well, when he can launch something into space, then he can come back and have a chat.
The cheek of the man. I mean, Blue Origin, as you know, has been going for 2 years longer than SpaceX and has never got one thing into orbit in, what is it now, nearly 24 years?
Yeah, something like that now. Yeah.
And except he's never got anything into orbit. We know his tourist flights in the.
He's given all these NASA contracts.
Yeah, Blue Origin are winning loads of NASA contracts for a spacecraft that doesn't actually exist yet and has never flown. Which is worth millions, and it's absolutely crazy. But there you are. Also, Boca Chica. It looks like SpaceX are planning something a little interesting. Now, as you may know, viewers, the next flight test of the Starship IFT-5 is now scheduled for late July, and what they're going to do is try and catch the returning booster on the launch tower using those massive mechanical arms. We keep saying this is pure Thunderbird. So the booster will come down right next to the tower. It proved it can do a positioning like that on the previous flight test, IFT-4, when they got it to land right next to a virtual tower in the Indian Ocean. Proved it can be landed with pinpoint accuracy, and it needs to be because they've only got a sort of play of a few centimeters for its position next to the launch tower when those mechanical arms close and catch it, and then after the engines have stopped firing, lower it to the ground. Well, they're going to test this by dropping a test tank into the arms of the of the tower, the chopsticks, and they've got a test tank which is a sort of a mini booster, if you like. It's not that big, but they're going to drop that from just above the arms into the arms to see whether they can catch it and whether it stays caught. So that's something to look forward to. That may happen tomorrow, actually, because the roads are closed tomorrow. So keep your eye out for that.
You're going to use that original hopper little thing?
No, that's full of holes.
Thanks. It's also full of cameras.
Yeah, it's full of cameras and all telemetry stuff, but it's full of holes since the first test. So yeah.
We won't be covering this live tomorrow because we don't know what time it's happening. It could happen any time during the day. But if you keep your eye on channels like NASA Spaceflight and Launchpad, if they even get a whiff of something happening, they will sit there for hours covering it, waiting for something to happen.
Yeah.
So that's quite interesting. So we'll see what happens with that. But IFT-5 is going ahead. The ship that is going to make the trip, Starship 30, has had all of its heat tiles removed. They've put a new ablative layer underneath the tiles, and they've replaced the existing tiles with tiles that are meant to be twice as strong. So hopefully that will stop the Starship melting like it did in places on the previous flight. Okay, we will return in about 45 minutes then. We have to say in advance that the chances of a launch tonight are not looking good because of the weather. 30%, wasn't it, Michael? Something like that.
Yeah,
Something like
30%.
Yeah, 30% chance that we'll launch tonight, but we're going to be here anyway. If the launch is cancelled before that, we will edit the title on the channel of the live stream, so it says launch scrubbed or something like that. So you'll know it's not happening. If it doesn't happen, there's another opportunity tomorrow. I presume that's going to be at the same time. I don't know. Anybody seen anything?
Well, because you say there's a 2-hour window, so if that's the case, then it probably will be around about the same time.
Yeah. Keep your eye on the channel, because what we'll probably do if it's not happening tonight, I'll just reschedule the stream for tomorrow. So keep your eye on the channel. Keep your eye on the Facebook page as well, where we tend to announce things. And thank you all so much for being here. We do appreciate it.
It'll be a bit ironic that the weather stops a weather satellite, won't it?
Yeah. There's a bit
Doesn't
of
want to give away its secrets.
Yeah. And finally, just to remember, if you would like to have your images featured in our weekly viewers gallery, send them in an email, 1 image per email, please, to spaceodditieslive@gmail.com. And if you could put the word gallery in the title of the email, that would be fantastic, so that it will get picked up automatically. And also, obviously, in the email, give us the details of the image, how you took it, what equipment, exposure times, things like that. You know how to do it. So any images you've got, please send them in to us, because we do love looking at them. Okay, well, that wraps things up for tonight. Thank you for being here. As always, viewers, we hope to see you back in about 45 minutes for this.
Well, it's about 30 minutes now, Andy.
Is it?
Yeah,
Yes, that's right. About 30 minutes. Gosh, doesn't time fly when you're having fun? Full details of the GOES-U satellite are in the description of the live stream if you want to read about it before the launch. But other than that, if you don't make it tonight, we'll see you back here usual time next week. And from all of us at Space Oddities, thank you for being here and goodbye. Have a great week.
See you soon.